Assalamualaikum warahmatullahi wabarakatuh. We are from Group 5, consists of Adelia Sulistiani, Iksan Budiman, and Iqbal Baheki Firdiansah. We'll present our big task about computer simulation assignment. In experimental unit, the chosen that we made as a simulation model for this task was a model from an Indomaret cashier queue located at Telkom University, precisely in PGA, which has several cashier machines, and cashier machine being there consists of several types of banks that are actively operating in Indonesia. So for the problem identification is we want to identify from our chosen experiment unit is the length of queue during the transaction process at cashier. Okay, next is simulation purpose. We have two purposes. The first is we want to minimize the queue length which usually occur during each of the cashier transaction process. And the second, we want to know the required time for each customer transaction. So in simulation requirement, we have for the requirement, the first is source, and the second is multiprocessor, so the third is sync, and the fourth is queue. Okay, next we go to the factor for experiment. In this slide, we identify experimental factor of variable and level of factor. The first is in the controllable input, we have amount of cashier, queue capacity, cashier machine which have a slow process, and the last is process time. And in uncontrollable factor, we have the cashier machine which suddenly get error, so the customer will suddenly need to find something missing, so the electrical power source will suddenly get turned off, so and the last is the customer do a transaction more than one. And for the level of factor, cashier machine, the first is slow process on cashier and the fast response on cashier. Next, we go to the collect and process data. In this slide, we determine data requirement like entity, resource, and location. In entity, we have arriving and departing customer. So in resource, we have cashier operator and cashier machine. And in location, we have cashier spot payment. And next, we identify data source. The first is personal observation is time study, and research literature is predetermined time study, and system documentation is facility layout, and so design estimate is queue time, processing time, and system time. Still in collect and process data, we have three steps to collecting data. The first is determine all of the entity flow. The first is customer, so go to waiting line, so cashier spot, and the last is exit counter. So next in description development from operation, we have this table. As you can see, the first is the location waiting line, so activity time, activity resource, next location cashier spot, move trigger when cashier spot is available, so move time, move resource, cashier spot, normal, exit counter, and finish. And in assumption making, we have 30 data of arrival time, begin service, service time, departure time, time in queue, and the last is time in system.
Okay, now we are going to the statistic analysis numeric data. The first is run test. The H0 is data doesn't have autocorrelation or random. The H1 data does have autocorrelation or unrandom. And since the result that we get from run test is a SIMSIC value is 0.353, which is the score is more than 0.05, then our H0 is accepted. Next is normality. The H0 is data distribution normal. The H1 data is in distribution normal. Since the result that we get from one sample Kolmogorov-Smirnov test is a SIMSIC value for arrival time is 0.2, which means the score is more than 0.05. And for begin service, we got the score is 0.108, which is the score is more than 0.05. And for departure time is 0.068, which is the score is more than 0.05. Or we can conclude that our H0 is accepted. Now we are going to the homogeneous test. From our result, we get the value out of limit is minus 1.96 and 1.96. So we can conclude that our model has heteroscedasticitas. And now we are going to the test distribution. This is the inter-arrival time result for test distribution. The exponential, log normal, and normal is acceptance. And we got one reject on the uniform. And this is for the process time. The acceptance that we get from this test distribution and process time is exponential, do not reject, log normal, do not reject. And for the normal and uniform, we got rejected. And now we are going to the part building a conceptual model. The first one is our input and output diagram. Start from amount of cashier server and the output is customer service. And this is our influence diagram. There are 5 uncontrollable input. The first one is amount of customer, amount of arrival customer, amount of transaction, error machine, source power which is get turned off. And there is one controllable input. The first one is regulation amount of machine. And there are 3 system variable. The first one is queuing time, processing time, machine available. And the last is output. We get one output which is time minimization in customer queue. And this is our EFD. The first input is person. Person will go to arrival place and the output from arrival place is person, and then the person is go to waiting line and the output of the waiting line is person again, and this person will go to cashier and the output from the cashier is the customer has been serviced.
So this is our building simulation model. We have one straight line model simulation, and we only have one server or one cashier support and one operator. And this is our verification. So we have to compare our conceptual model with our simulation model, which is our conceptual model or our simulation model can represent it, the conceptual model. So we compare and we get the result. The result is simulation model can represent it, the conceptual model, because in conceptual model there is a flow. When some customer arrive, we can get interarrival time and process time. So we can calculate how many people queuing before get the service. From operator cashier and from simulation, we can get how many people queuing before get their service. So we can conclude that our simulation model can represent the conceptual model, and our simulation model is verified. After doing verification, we going to doing validation. Uh, we using the statistical method such as ANOVA to find does our model regression is fit or not. So we doing validation using ANOVA, and we have a statistical assumption for H0 model regression is not fit or worth to use. And this is our result of our first simulation model. On QU arrival, the maximum content is 6. It means the maximum number of people queuing in the QU arrival is 6 people. And for the second result is for processing cashier's spot, and the result is number of output is 340 and 3 people, but there is an idle time is 50.3%. And this is our scenario or our design. So flow process begin by the arrival of customer. In the arrival customer has an exponential distribution, which is 0 and 3.82 minutes, and after that customer will enter queue or waiting line. Customer will stay in waiting line if cashier spot is not available. Customer will go to cashier spot through waiting line if cashier spot is available. Then customer will get service from one operator cashier with exponential distribution of process time, which is 0.02 and 2.1. And after get service from operator cashier, customer will go to exit counter and system will repeat the flow till the predict system is shut down. And this is our second simulation or our improvement simulation. Um, what is the minus benefit or minus of simulation of the first model simulation is the first model simulation has the we want to reduce the maximum number of paying of people in the query arrival. So we adding one more cashier spot and one more operator, and then the result is after this slide, and this is we want to run the simulation and how the result, and next slide. And this is our analysis simulation result according to the scenario of the second simulation model. For the first result, we success to reduce maximum number of people from 6 people to 3 people. And the second result is number of output is 340 and 3 people, but there is an idle time is 63.4%. And for the third result on the second server or cashier spot, the number of output is 152 people, but there is an idle time is 83.3%. And this is our conclusion. I'll report the results and recommendation for system improvement. And so we get conclusion of the simulation. On first model simulation, we using one server, one cashier spot. The result of first simulation model is number of queue people is 6 people, and number output of cashier spot is 343 people suffice, and idle time is 50.3%. Our objective is one to reduce number of queue people. So we add one cashier spot and we use two server and two operator. That is our improvement, and that our improvement is represented of or from the second simulation. So, and the result is we success to reduce number of queue people from 6 people to 3 people. Number output of people is increased than before, but the number percentage of idle time is increased too. For first server is 63% and for second server is 83.3%. And thank you for your attention. And sorry if there is mistake of saying and everything. And once again, thank you for your attention. This is our computer simulation assignment. Thank you. Wassalamualaikum warahmatullahi wabarakatuh.